Hi friends, welcome to my channel. I hope all of you are doing good. So in this small video, we'll understand the Faraday's second law with the help of a small practical experiment. So what Faraday's second law states? It states that the induced EMF in a coil or a conductor or a conducting coil is always directly proportional to rate of change of flux linkages. We know that the flux linkages are nothing but the product of the number of turns and the magnetic flux phi. Here in this small video we will consider two different situations where in both the situations we maintain the same change in flux, means the d phi by dt change in flux with respect to change in time. In both the cases we maintain the same change in flux, but we change the number of turns so that the total number of flux linkages changes. Here if we maintain d phi by dt as constant in both the situations, now the induced EMF depends upon the number of turns that a particular current carrying coil contains. So when the number of turns increases, automatically the induced EMF increases. When the number of turns reduces, automatically induced EMF reduces. We can understand this concept with the help of a small practical experiment. Okay, let us see that. Thank you very much. Here the important observation to be made in this experiment is I have taken 3 coils. The first coil purpose is to provide the required magnetic flux. So the first coil is excited with the help of 2 batteries that are connected in series, whereas the second and third coils are used to check whether the electromagnetic induction works here. So there will be an electromagnetic induction from the first coil to the second and third coils. In the second coil I have taken this with 100 turns, whereas the third coil is taken with 800 turns, and we will see the illumination of an LED which is connected to the second and third coils. Let's have a look on the circuit which is used to excite the first coil. Here the switch and one of the coil and 2 9-volt batteries all are connected in series, and this switch is used to make and break the circuit. When the switch is in on condition, the current will flow, otherwise the current will not flow. And if you observe the battery, the negative terminal of one battery is connected to the positive terminal of another, so that they are connected in series and giving a total voltage of 18 volts. This is one coil which is wound with 100 turns, and these are the 2 leads of the coil, and this is another coil which is wound with 800 turns. These are the 2 coils which are connected to LED in order to observe the electromagnetic induction. This is the LED which is placed on the breadboard. Now, how to place the first coil, which is the exciting coil, the coil which is connected to the battery, on the other coil. So I just placed the exciting coil above the 2 coils, one with 100 and another with 800. So in between them I placed a paper so that there will be no direct connection between the exciting coil and the second and third coils. Okay, and the second coil and third coil leads, the 2 leads of the second coil and third coil are connected to the LED. So whenever we change the flux linkage, whenever we change the current flowing through the first coil, there will be change in the flux linkage when we change the number of turns. If you want to observe the illumination of an LED with only 100 turns on the secondary side, you can observe only less amount of illumination. That's why I have taken this illumination with room lighting off. And this is the case with 800 turns. So even with the room lighting on, we can observe its illumination, because as the number of turns increases, the induced EMF increases. If the EMF or the voltage that is applied to an LED increases, automatically the glowing or the illumination of the LED increases. That's why the illumination of LED with 100 turns is very much lesser than illumination of LED with 800 turns. I hope you have understood Faraday's second law with the help of this small experiment. Thank you very much for watching this video. If you like this video, please share this video and subscribe to my channel.